Hello. Today we'll discuss the topic upper confidence bound algorithm of reinforcement learning. Actually, upper confidence bound is a concept of finding out the uppermost uh, level of confidence, uppermost level of confidence of selecting the arm from in a multi-arm bandit system. The UCB algorithm actually is a popular and effective bandit algorithm which addresses the exploitation trade-off by using the exploitation trade-off by having the balance between exploitation in a multi-arm bandit problem. It chooses the optimal arm that gives the best reward. Actually, it is helped agents to make decision in an uncertain environment where the actions are not having the probability distributions of actions are not known to the agent, and there is a limited feedback. There is a limited feedback from the environment. There is a limited chance of reward that coming from the environment. The arms correspond to the actions. And in multi-arm bandit system, each arm correspond to an action. Now, exploration, as we know, that trying a new arm, completely new arm, which is unexplored so far, to exploring a new arm, absolutely new arm, which is unseen, which is unassessed so far. And the exploitation represents the fact that the arm which is best performing so far, that arm is selected. That is exploitation. Or the Q value, what is generated so far by whichever action and the arm, corresponding to that particular action, that arm will be chosen. That is the exploitation. Now, the UCD algorithm balances between exploration and exploitation, and it gives a perfect trade off between them. The algorithm, the agent's objective is to maximize the cumulative reward as usual over time by selecting the best performing arm. So, either if it the best performing arm from the set of all the arms already explored, and on the basis of the best Q value arm, the best performing arm is chosen as we refer as exploitation, or the if the exploitation is not happening in that case, to choose a completely new arm which is unexplored to the test the outcome of that particular arm. However, the agent initially has limited knowledge about the true reward distribution of each arm. Agent doesn't know about the true reward distribution each arm, what the arms are giving the rewards, which rewards are earned by which arm. That particular information is very limited to the agent. So it is actually going forward by a mathematical process where a particular known arm, there is a known arm, and there are all the other arms are there. So choosing the arms which is not known, which is not explored, is going in account of exploration, and the arm which is already known to trying that arm again and again, that is the exploitation. And the definitely the already explored arm among which whichever is giving the best Q value. Now the algorithm we can see that the operation of the algorithm starts with the initialization, that initialize the algorithm by assigning initial value or estimate to the action values to each arm's action value. So the arm which is corresponding to an action, and what is the value of that action? What how good the action is that represented by some value. The value is assigned to each arm. So initialize the algorithm by assigning initial values or estimates to the action values of each arm. So action values are given some score of each arm. Each arm is corresponding to an action value, and action values are assigned by some scores representing its goodness to take you to the better state. The action selection is done at each time step by the ensuing algorithm with a higher, the action is chosen at a higher confidence bound. The action which is having the upper confidence bound, that action is chosen. How the upper confidence bound is determined, it is based on the current estimates and an exploration parameter. So there is an exploration parameter that determines the rate of exploration, that determines the rate of exploration. If that parameter is higher, it is referred as C, then the more exploration it will be taken place. Otherwise, the current estimate, currently whatever actions are estimated, among which we choose an action, so that is the exploitation part. Or otherwise, the exploitation part will increase. So either of the exploration or exploitation, if exploration increases, definitely exploitation decreases. If exploitation increases, exploitation increases, definitely the exploitation is going to decrease. So in this trade-off of exploration and exploitation, the upper confidence bound is determined and the maximum value of the upper confidence bound is selected and the responsible action is chosen as the optimal action to be taken and the corresponding arm that is chosen, which is correspond to that particular action. So the arm which is chosen that corresponds to some action that gives you the highest confidence bound or uppermost confidence bound. So now the UCB value for each arm is calculated using a formula, which is the formula is you can see UCB equal to QT of A plus C into square root of log T, actually 2 log T. It can be any constant log T. Ideally, it is 2 log T divided by NT of A. What is that UCB of TA? Is the UCB value of action A at time step T. UCB value, there is a value of action that is given. That's the UCB value, upper confidence value of the action at time step T. In time step T, what is the upper confidence value of the action? The action that gives you the upper confidence level, and that is equal to the QT of A. QT of A means the Q value that is generated by A, the action A so far. So QTA is a current estimate of the action value for action A at time step T. It's a current estimate of action A at time step T. That is QTA. It's an action value, means it's a Q value. It's a Q value or action value. The value of the action currently estimated. Okay. Which is already estimated. We have estimated the action value. So this is exploitation term. QTA is the exploitation term, which is already estimated, the value of that action. Okay. Is a absolutely correct estimate of the action value for action A at time step T, or we can say it's a Q value of action A, current Q value of action A. So we have all the available Q values of action A. So is the add in all the actions already explored. So we have A is one of the explored actions. Small a is one of the explored actions, and we have the current estimate of Q value due to that action A. And there is a C multiplied by root over log T divided by NT of A. Log T, actually it is 2 log T, but we can say we can ignore 2 here, but actually it is 2 log T, or we can also give some other constant value, 3 log T or 4 log T, but ideally it is used as 2 log T. So C is the rate of exploration. First term is the exploitation QT of A, is a Q value on so far by the action A. If the action A is chosen, action A is a good action. that takes you to the beta state. And this is C into root over log T divided by NT of A. NT means 80th timestamp up to Tth timestamp, the number of times action A is tried, the action A is played, or action A is taken, or arm A is played. The number of times, total number of times arm A, eighth arm is the A arm is played, or the action A is chosen, or the action A is chosen. A is an arm that corresponds to an action. This is the arm already estimated Q value of arm, that is QTA, which stands for exploitation. And NT of A, the number of times that particular arm A is pulled, and the T's, only T, is the total number of times all arms are pulled. The total number of times that all arms are pulled. This means total number of arms are pulled. Okay. The total number of arms pulled, or the total time, total amount of time, all the arms are pulled, that is represented by the variable T. So log T, why we use log T? We scale down, we scale the T number of trying of all the arms, T number of playing of all the arms, we scale down by log T. So we'll reduce the effect of the, the overall exploration. We reduce the effect of, we scale down the effect of total exploration, we scale up by log. Is a logarithmic scaling we are done to reduce the effect of the blind exploration to all the arms. Because except the arm A, all the other arms are unknown. All the other arms are unknown. So T means the total number of times exploring all the arms is actually representing the randomness, the random behavior, or we can say it's an exploration. So we reduce that particular effect. We use the log of T that will scale down the total number of random selection of arms. So now, as in the algorithm, we can see, if NT of A, the number of times arm A is played, arm A is a known arm. If it is rising, if it is increasing, then definitely the ratio of log T divided by NT of A, that ratio log T is to NT of A, that particular ratio will decrease if the number of times known arm A is played. So at a time, if the known arm A is, the number of times the known arm is played is tending towards infinity, definitely this term will, this whole term, this ratio log T divided by NT of A will tends to zero. That leads to the exploration tends to zero. So exploration is almost going vanished. And C is a constant multiplied by this exploration term is actually the rate of exploration. C, higher C value corresponds to higher rate of exploration, lower C value. If C is lower, that corresponds to lower rate of exploration. So C stands for exploration exploitation trade-off. Again, if the value of C is higher, which represents the higher rate of exploration and the lower rate of exploitation, and if the value of C is lower, that represents lower rate of explorations and higher rate of exploitation. So definitely, whatever the value of C is, it is multiplied with this particular square root term. That square root term, that is square root of log T divided by NTA. So if NTA rises, the square root term will decrease. This means exploration term will decrease, multiplied by the rate of exploration, that is a constant value. So this total term will definitely decrease if NTA will increase. And as a result, this QTA will also increase. If NTA will increase, NT of A, number of times arm A is played is increased. So QTA will also increase because the number of times the arm will increase, the amount of Q value that is generated, that is a action value that is generated by pulling the arm A, by playing the arm A, will increase. As we use more and more times A, so Q value of A, time step T will increase. So the exploitation term will increase. So either QTA will increase, the exploitation will increase, or NTA, if NTA will increase, then also QTA, the exploitation term will increase. And automatically the exploitation will decrease. And similarly, if NTA will decrease, so number of known arm A is not used that much, not used so much. In comparison to that, the other arms, which is not known that much, the other arms are used, other arms are played in more, in a higher rate, much higher rate and higher frequency. So in that case, T will rise, or if T will be fixed, if T will rise, if T is fixed, NTA will decrease, then the ratio will increase. Now, if T will increase, NTA is fixed, then also this ratio will increase. If the number of times arm A is played is fixed, and the number of times all the arms are played, this means, which is increasing, means the arms other than arm A is played more. In that case, the exploration that represents the exploration increases. Exploration increases. Q value will not increase, but exploration will increase. Exploration will increase. So the ratio will increase, exploration will increase, multiplied by the rate of exploration. So it will have a total overall increase, the exploration. But our motive is to find the best arm that will optimize the Q value. That is optimize the QT of A. That is maximize the QT of A. So this whole function, QT of A plus C into root over log T divided by NTA, this whole mathematical expression is called the upper confidence bound. Now we have to choose that arm which will maximize the upper confidence bound value. Is the argmax of A. We will choose that arm A, which is used to maximize that particular UCB, QT of A plus C into root over log T divided by NTA. That particular term. We'll choose that arm. Arm means action here. Each arm is corresponding to action. So we'll choose that arm, and that arm is assigned to the chosen arm, capital AT, at time step T. So now we have the third step of this. Fourth step, action, execution, and feedback. Now you take that action according to this particular UCB. You take the best action. You take the action that maximize that particular upper confidence bound. That will increase the upper confidence bound. And here the upper confidence bound, again I'm telling, if exploration increases, definitely exploitation part will decrease. If exploration increases, it can happen if T will increase, NTA is fixed. In that case, the exploration term will increase. If T is increasing, NTA is decreasing. So definitely if T is increasing, NTA is fixed or decreasing. In both the cases, the exploration part will increase. Okay. Now after that, if exploration part increases too high, then it will be alarming for the agent to choose for that exploitation to use the arm A, already known arm A. So again, the NTA will rise, then the ratio will decrease. Ratio is the exploration will decrease. So the ratio of the total arm is to the known arm, that ratio will decrease if NTA will increase. So in that case, the exploration increases, exploitation increase. So it is a trade-off between exploration and exploitation, is a balance between the exploration and exploitation. And we add up these two terms, the exploration, exploitation, and finally we choose the maximum of this sum, and the action which is responsible for maximizing this exploration plus exploitation, the sum of these two, and we choose the corresponding arm. Now the fourth step tells that action is executed means the arm is played. That arm which maximizes this function. Okay. After that, a reward is earned. Fifth step, the reward updated. After receiving the reward, the algorithm updates the action value estimates for the chosen action based on the observed reward. Whenever the reward is earned, immediate reward is earned, then the total cumulative reward is updated. Receiving the reward, the algorithm updates the action value estimate. Action value estimate means the Q value. That is updated, means cumulative reward is updated. The reward is earned, that is added with the previous cumulative reward, will make the new cumulative reward, and definitely the Q value will be updated. The action value estimate, which means the Q value, that action value will be updated. For a new reward, the action will earn a new value. So previously calculated action value will be updated by the new action value. Okay. Now, repeat step 2 to 5. Step 2 to 5. Whatever step 2 we had it. The step 2 from taking action. Then after that, we have this UCB and the choosing the arm according to the maximized UCB. And then we have the action execution and reward. Then we update the reward and the Q value or action value. And then we repeat these 3 steps, 4 steps. Number 2, taking action. Number 2, first, you see, we can retrospect there. The number 2, the second step, we have the action selection. The third step, we have the UCB calculation, action selection. UCB algorithm selects the action with the highest upper confidence bound, and we choose the arm on the basis of that particular UCB formula. After that, we have the feedback, that is reward, and reward is updated. These all 4 steps are repeated for a predefined number of time steps or until stopping criteria is met. There is a termination criteria. Till that time, these 3 steps will be action taken, and action is chosen, and UCB is calculated of that actions. And the UCB, whichever is offering the highest UCB, that action is chosen from the all chosen actions. First, the action is chosen. Several actions are chosen, means several arms are tried. Whichever arm or whichever action gives the maximum UCB value, each action or each arm will yield some UCB value, that is QT of A plus C into root over log T divided by NTA. That is actually it is 2 log T. So that is a UCB value. Each action is correspond to, each arm is correspond to. So there are a number of actions, number of arms are played, a number of UCB values are computed. And after that, we choose the best action or arm that gives the highest UCB value of all the UCB values. Third step. Fourth step is after taking that action or after playing that arm, whatever reward is earned, we observe that reward. Fifth step, after achieving the reward or after receiving the reward, we update the cumulative reward and update the Q function, or we can say action value. And we repeat all these steps till the uh, predefined number of time steps, uh, for the predefined number of time steps, or till the termination condition is met. Now, by using the UCB formula, the algorithm leverages the uncertainty in the estimates to guide the agent towards action that have the potential for higher rewards while exploring lesser known actions to improve future estimates. Now, the lesser known action and the already known action, to have a trade-off between them. Either lesser known actions are being explored, or the already played arm or already known action is recultivated to get that which get the highest action value so far. Now, either exploration or exploitation or the trade-off between them. Some exploration, some exploitation, some mix of them, or otherwise full exploration, sometimes no exploitation at the beginning. It is at the beginning when exploitation is not that way. But actually, we are going to optimize the upper confidence bound is actually a maximum value of Q T of A. That is maximum action value. That is actually the upper confidence level. So finally our motive is to maximize this QT of A in this equation. Ultimately, our motive is to maximize the QTA of this equation and to almost make this exploration term be vanished. Almost we have to vanish this the exploration term of this particular equation so that NTA will tends to infinity. NTA will tends to almost infinity. The number of times the arm A is pulled is increasing to A, and the number of times the other arms are played is not increasing. Okay. In that case, this ratio will decrease and closes to zero, if not exactly zero. If it is tending towards zero. So exploration tending towards zero, and the term exploitation only remains in the equation almost. And we maximize that maximized Q value. We'll consider the maximized Q value to find the arm or action responsible to maximize that Q value. So that is already explored arm, already explored action. The best explored arm or best explored action will choose at the end to so that which has earned the best or highest Q value or action value so far. So this is the motive of this algorithm. So thank you so much. And next lecture video will discuss the other algorithm of Q value.